Alright, in this video I'm going to be showing you converging and diverging geometric series. I'm going to give you an example of a converging series and two diverging series. It's really straightforward stuff. This is probably the fanciest idea we've seen all year, but in terms of executing it, it's really not very difficult to think about. So let's say I take a geometric sequence, simple one here, 1, 1/2, 1/4, 1/8, ... meaning we're going on forever. Suppose we did a series, but we added up every single term in the sequence. Well, the ... means it keeps on going, which means it keeps on going, which means it goes on forever. So what we're going to be doing is adding up an infinite number of terms. Naturally, we would think if we're adding up an infinite number of things, we'll get infinity. But we're going to see something interesting happen here. So let's have a number line, 0 through 3. And I'm just going to start by listing the first 10 terms of the sequence I showed you. Alright, and this is what it looks like. A little spooky, but it's alright. Alright, so we're going to go ahead and start summing these up. Alright, so start with 1. Running sum of 1. We'll put the point there. 0.5. So now we've got 1.5. 1 point goes there. So we've added up 2. And that's, we're landing at 1.5. Now we'll add the third one in, 0.25. So it's a 1.75, so that's where we're landing there. Alright, let's add 1/8, which is 0.125. Alright, so 1.875, so it looks like we're kind of getting close to 2 here. We should probably zoom in a little bit because, we're going to be looking at smaller and smaller decimals, so let's go ahead and just really hone in between 1 and 2. These are still the first 4 terms summed together. Alright, so now we're going to go ahead and do 1/16, which is 0.0625. Okay. And that's going to sum up to 1.9375. Alright. And that's about where that point would go. Alright, so now we're going to do 1/32, 0.03125. Going to sum that up, 1.96875. Alright, there's that point. It's getting a little crazy here. So now 1/64, we're looking at 0.015625. Really, really small. So we're talking like, if we're thinking about fractions as a dollar, we're looking at like 1.5 pennies. I'm going to go ahead and add that up. I get 1.984375. Alright, now pay very close attention, and there's the point. Alright, did you see how little that moved? That's kind of crazy. So, we get the picture. If I added up the first 10 terms, I would end up with 1.998046875. Really, we start to see here that if I add up any finite number of terms of this sequence, I'll get wicked close to 2, but I'll never truly be 2. However, we are adding up an infinite set of terms of this sequence, so we will end up getting 2. So what I hear a lot of kids say is after we add up an infinite number of things, we get 2. Well, the word after and infinite is kind of a weird way to think about it. But the way that we would describe this is we would say that the series 1 plus 1/2 plus 1/4 plus 1/8 converges to 2. So in short, a series converges if I get a specific number when I add up an infinite number of terms in the series. Alright, if a sequence doesn't converge, let's say I just took the denominators of all those things, so 1 plus 2 plus 4 plus 8. I think this time it's really obvious that if I sum up all these terms, I'm going to get infinity. So if I sum up an infinite number of things which are positive and getting bigger, then we're looking at infinity. So we would say this series diverges, because if it adds up to infinity, well then it's not going to a specific point. We don't say it converges, we say it diverges. Similarly, if I made all those numbers negative, it's pretty obvious here that if I sum up all the terms of this series, I would get negative infinity. Still, we would say that the series diverges. Alright, so let me recap. A series converges if I get a specific number when I add up an infinite number of terms in the series, and a series diverges if I get an infinity, positive or negative, when I add up an infinite number of terms in the series. I hope this makes sense. It's a little bit of a crazy idea, but in the last flurry of animations, I hope that you kind of saw what happens as we add up more and more terms of that series. Alright, good luck with these problems.